Okay, equations with compound angles. So, when we're solving these trig equations, we're not always just going to be asked what is x in this situation. Okay, because that would be like us asking all the time, x is equal to 5. So what is x equal to? Well, x must be equal to 5. 5 is equal to 5. Hooray, we did it. That would be too easy. Okay, obviously it's a little bit different than that, but more or less that's what we're doing. We're trying to find which value makes this true. Okay, well, put some numbers in, it works. When we have compound angles, it's more like applying one or two more things to the problem. Now, when we solve these, there is a method that we need to do. Okay, and so that method is called a substitution method. Okay, so to solve, we'll write down the list of things that we're going to do. So what we're going to do is we're going to let u, whoa, that was gross, let u be the compound angle. Okay, so when I refer to a compound angle, I'm talking about if I had, say, cos of 2x, okay? So instead of cos of x, it's cos of 2x, okay? And so what you would do in that case, so cos of 2x, you'd say, okay, we'll let u be equal to 2x, okay? Like that. And then you can rewrite that as cos of u, okay? So that's more or less what you're doing. Okay, so step 2 after that first step, so step 2 is to find the restrictions. Find the restrictions on u from given restrictions on x. Now I'm going to show you how to do that in the examples because I think it's just much easier to show you when we've actually got an example, but it's not too hard. Okay, then what we're going to do is we're going to solve the trig equation for u. Okay, so treat it like, go through the list of how we solve the other ones. Okay, and then the last step is then to hence solve for x. And we're going to use some substitution to do that, okay? So that's basically our short list of things that we're going to be doing. And now let's go and see how to actually do them. So what we're going to do first is we're going to solve each of the equations for x between 0 and 180 degrees. And our first one is cos x over 2 is equal to 1 on root 2. Okay, so what we're going to do first is we're going to start off by letting u be equal to x on 2, okay? And I'm just going to rewrite this up here so I remember what it is. X cos on 2 is equal to 1 on root 2. Okay, so let u be equal to x on 2. So that means that then cos of u is equal to 1 on root 2. Okay, so see how we've changed it from being cos of x over 2 equal to 1 on root 2. We've just removed the x over 2 and just changed it to a single variable because we know what that's actually equal to. Okay, and then we're going to do that in a moment. Okay, so the restriction, the restriction on x is, our restriction on x is still this one. So whatever x is, it's between 0 and 180 degrees. The restriction on x over 2 is, well, we're just going to divide both of our boundaries by 2. Okay, so if x is between 0 and 180, then if I'm effectively halving all of the possible values of x, that means x on 2 must be between 0 and 90 degrees, okay? Because I'm saying divide this by 2 and divide that by 2, okay? 0 divided by 2 is just 0, 180 divided by 2 is just 90. Okay, but we know that x on 2 is just u, so on u it is 0 degrees is between, or u is between 0 and 90 degrees like that, okay? So this is basically just setting up our restrictions on u. So we're looking for when cos of u is equal to 1 on root 2 between 0 and 90 degrees. So we want cos of x on 2 between 0 and 180, but it's going to be an equivalent expression of cos of u between 0 and 90 degrees. Okay? So, to continue on, what we need to do now is we need to find, well, when is cos of u equal to 1 on root 2? Okay? Well, let's start off by drawing up our compound or our quadrants. Okay, so all stations to Coaldale. Okay, now when is cos of u equal to 1 on root 2? Well, we know it's only equal to that in the first and the fourth quadrant. However, my restriction on u says that I'm only looking for the quadrants between 0 and 90 degrees. Or in other words, I only care about that first quadrant. Okay? Now, when is cos of u equal to 1 on root 2? Or for what value of u is, what angle gives me 1 on root 2? Okay, well 1 on root 2 is the same as root 2 on 2, and I'm hoping we remember our special angles, and we must mean that u has to be equal to, well, cos of what is equal to 1 on root 2? It's 45 degrees, okay? Because cos of 45 degrees is equal to 1 on root 2. So u is equal to 45 degrees. So again, this is our u value, so u is equal to 45 degrees, okay? And that's that one there. Okay, so our ray is 45 degrees in the u. Now, we need to go back to our restriction. So, but our restriction says that because, well, x, what is x? How is x related to u? Okay, because we don't care about cos of u. What we're trying to answer is, well, when is cos of x on 2 equal to 1 on root 2? Okay, so if, let me write it like this. So if u is equal to, what do we decide? If u is equal to x on 2, then x must be equal to 2 lots of u. So my restriction is going to go back. So by effectively doubling u, my restriction is going to go back to, between 0 and 180 degrees, okay? But what does that mean for x? Well, if x is 2 lots of u and u is equal to 45 degrees, then x is equal to 2 lots of 45 degrees. So x is equal to 90 degrees, okay? And that's effectively how we answer it. Okay, so basically you halve your answer and then solve it as you normally would, and then you basically say, okay, what did we do to it? Let's pull back what we did. Okay, so let's do part B, and hopefully this one will make it a bit clearer. So part B was sine of 2x plus 15. So remember, this is all within the brackets as well. I should make a point of saying. So sine of 2x plus 15 is equal to a half. Okay, so again, we're going to start the same way. So let u be equal to 2x plus 15. Okay, so that gives us sine of u is equal to a half. Now we say to ourselves, well, when is sine of u equal to a half? Okay, well, let's go back to our quadrants. All stations to central. Oh, actually, before we do that, we need to do our restrictions. Yes, can't forget the restrictions. So, our restrictions on x are that x is between 0 and 180, so that's just from the question. Okay, so our restrictions on 2x plus 15 are that we're going to double this number and add 15 to it, so 0 plus 15, well, that's 15 degrees. And 2x plus 15 is going to be between 15 degrees, and I'm going to double 180, so that's 360, and then add 15, so that's 375. Okay, so 375 degrees. Okay, so that's our new restrictions. So on u, well, that's just 15 degrees, u, 375. So basically, we're going back and doing what we did in these last few examples, okay, by doing effectively this, but instead of doing x, we're doing u, and then we're just reapplying what we've done, like what we did to the x in the begin with, like we multiplied by 2 and added 15, so we're just redoing that, we're doing the opposite of it. Okay, so to get my sine of u is equal to a half, I'm going to draw my quadrants, I'm going to do my all stations to Cardiff, okay, And we are going to put in our sine of u is equal to half. So when is sine positive? Well, it's in the first and the second quadrant in this case, okay? So sine is only positive in those two, okay? So what is that angle in there? Well, when is sine of u equal to half? U must be equal to what? And we know in that case it must be equal to 30 degrees using our exact ratios, or exact values. So u has to be equal to 30 degrees. So in this case, sine of u must be 30 or 150 degrees for it to be positive, okay? So u is equal to 30 degrees and 150 degrees, okay? Because if I put sine of 30 degrees and sine of 150 degrees into a calculator, I get half back out in return. Now, continuing on with these ones, we are next going to reapply our restriction. So if u is equal to 30 degrees and 150 degrees, well, when is sine of 2x plus 15 equal to a half, okay? So remembering that we need to then effectively redo what we've done into our thing. Now, before we continue, we need to go back and look at our restriction, because remember, in this case, it doesn't matter as much, but we always need to come and look back over here and have a look and just make sure that we don't have any other possible answers. So it's between 15 degrees and 375 degrees. That is, it starts from 15 degrees and it does a full lap back around until it gets to 375, which is 360, which is 15 degrees. So back where it goes, but it's just 15 degrees pushed forward. Okay, so in this case, it doesn't matter because both 30 degrees and 150 degrees are the only two values when sine of u between 15 and 375 is positive. So those ones, we're just going to leave it as it is. Now, getting our x value back. So this is when sine of u is equal to a half, but we want when sine of, 2x plus 15 is equal to a half, okay? So this is the one we're actually trying to find. Okay, so to do so, basically we just need to do the opposite of what we did to get there in the first place. So we added 15 and divided 2. So let me write by this. So if u was equal to 2x plus 15, okay, then u minus 15 is equal to 2x, and then x must have been equal to u minus 15 all over 2. Okay, so what we then just need to do is just put these two values into this one here, and that will give us, well, what x must be equal to in our compound angle. So x is equal to 30 divided by 15. 30 minus 15 is just 15. So 15 divided by 2 is 7.5 degrees. And our other one was 150 minus 15, which is 135. I'm just going to do it here the long way because I don't have my calculator with me. Divided by 2 is equal to 67.5. Okay, so between 0 degrees and 300, so when x is between that and 180 degrees, these are the two values that makes it true, okay? So it's just applying basically what we've done, but either halving out that angle to begin with or adding something to it to begin with and pushing it around a bit. Okay, so that's basically it for this one. Okay, all you have to do is just really follow the steps for this and that will give you your answers. Any other issues, just make sure you let me know.